Hello, I'm Donghao. In this session, we're going to learn more about how to build great data visualizations with Swift Charts. In other words, we'll raise the bar of what you can do with charts in your apps. A great data visualization makes your app more informative and more engaging. In order to build a great chart in our apps, there are many things to consider. Of course, we want our charts to faithfully communicate the underlying data and be accessible for everyone. The charts in an app don't live in a vacuum. They are part of the app's user interface. We have to support localization and OS features like dark mode. A chart has to have a proper layout that fits seamlessly into the rest of the UI. It should support dynamic type and device screen sizes. We also want charts to work in all platforms and have great animation for the best look and feel. Swift Charts takes care of all of these basic features for you automatically, so you can focus more on building the best charts to communicate your unique data and make it accessible for everyone. Swift Charts achieves this by providing you with a declarative syntax that feels just like SwiftUI. You specify what you want in a chart with a small amount of code, and Swift Charts will automatically produce a great chart out of the box. Swift Charts also provides a rich set of customization options, so you can style the chart to match your unique application. This session is about giving you a deeper understanding of Swift Charts. We will start by covering the basic building blocks of the declarative syntax, marks, and the composition of marks. Here are some examples where we use charts in Apple products. As you can see, there is a wide variety of data, chart types, and styles. Instead of providing a pre-built component for each type of chart, Swift Charts is built on the idea of creating charts by composition. It provides a small number of basic building blocks, and combining them in different ways, you can create a wide range of charts. Let me show you how it works. To do that, I'll need an example. All of my teammates love pancakes, so we're having an app to track orders for a food truck selling various kinds of pancakes. Here is a chart showing the number of pancakes delivered over the last 30 days, broken down by style. This is widely known as a bar chart. In Swift Charts, we consider each of the 6 blue rectangles a mark. A mark is a graphical element that represents data. This is a bar mark showing the number of cachapas sold over the last 30 days. In this chart, we have 6 bar marks, each showing a pancake style, and the corresponding sales number. Let's see how this is written in code. Here we have SwiftUI view that includes a descriptive title like most sold style cachapa, and an empty chart. The chart type here is a top-level view that defines a single chart. You can add a chart in your SwiftUI application just like adding any other view. For the rest of the talk, we'll focus on the chart part. You can add marks to a chart. Here we have a single bar mark showing cachapa and its sales number. This makes a chart with a single bar mark. As shown in the screenshot, the chart fits nicely into the rest of the user interface and has a great default style. For example, nicely rounded numbers in the x-axis. If you add another bar mark with different name and sales, you get a second bar. You can repeat this to add more bars. In a real app, we will probably generate these marks programmatically. You can do so by providing an array of structs or tuples to the chart, and use a for each to create the bar marks with the values from each element. If for each is the only content in the chart, like in this case, you can also put data in the chart directly. Many SwiftUI modifiers are available for marks. For example, you could set the color of the bars with a foreground style modifier. Here, we are setting it to a named color, which can be created in Xcode as a named asset. It's very important that the chart is accessible for everyone. By default, the chart will be exposed to voice-over users with automatically generated accessibility elements. You can customize this with the accessibility label and accessibility value modifiers. Here, for example, we set a label to the name of the pancake and the value to the sales with suffix sold. As a result, you'll get a custom experience for voice-over users.
Cachapa, 916 sold. Injera, 850 sold. Crepe, 802 sold.
Our app also tracks pancake deliveries over the days. Here, we have a view showing the number of pancakes sold in the last 30 days. The chart gives a detailed view of each individual day. Let's see how to make this chart. Here we have a data array with day and sales. The day is represented by a date value at the start of the day. We visualize the data with bar marks, where x shows day, and the unit parameter here means that the date values represent the duration of a calendar day. And y shows the sales of the day. As you see on the right, we get a bar chart showing sales over the days. Bar chart is not the only way to visualize this data. Let's try a line chart. The only change we have to make is to replace bar mark with line mark. With a declarative syntax, it's very easy to switch between chart types in Swift Charts. The previous chart shows total sales over time, but the food truck service has been operating in 2 cities, and we would love to compare the sales between the 2 cities on each weekday to help us decide where to go. The lines in this chart shows the sales from Monday to Sunday. Each line represents a city. Let's see how this is built. Now suppose we have 2 cities data defined here with an array of tuples. Each contains city name and sales of the weekdays. Then we can wrap the line chart we had before with a for each that loops over the series data. In order to differentiate the 2 cities, we use the foreground style by modifier to style the 2 lines by the city name. As you can see, Swift Charts automatically picks 2 colors for the 2 cities, color the lines, and then add a legend to indicate what each color means. The default colors are chosen to be system colors that are easy to differentiate. To make the chart easier to read for people with color blindness, we can add symbols to the lines to further differentiate them. This can be done by adding symbol by modifier with city as the data. Finally, to make the lines look smoother, we can use a curve as the interpolation method for the lines. Even with the 2 series line chart, we can still go back to bar mark and see how it looks like. Changing the mark type to bar mark and remove the modifiers that aren't relevant to bars, we get a stacked bar chart. The bars are automatically stacked because we now have 2 bars for each month. While the stacked bar chart is great for showing the total sales value for the 2 cities, it's not very good for comparing between the 2 cities. To make it easier to compare, we can turn this into a group bar chart with the position by modifier. So far, we have seen bar marks and line marks. Swift Charts supports a couple of other mark types, including point mark, area mark, rule mark, and rectangle mark. You can combine these marks to build more complex charts. Let's see an example. Let's start with a line chart showing the average daily sales for each month. While the average is useful, we also want to see the minimum and maximum daily sales to get an idea of the more extreme values. Let's start by adding these values to the data. We introduce daily mean and daily max to each element in the data array. We can then visualize the mean and max with an area mark, where x showing months and y starts at the daily mean and ends at the daily max. This way, we have a chart showing daily average values with a line and daily mean and max values with the area around the line. A line plus area isn't the only way to visualize this kind of data. You can easily switch to other mark types to explore more design options. For example, here we are using a bar mark. However, the line doesn't seem to fit very well with the bars. Let's change the line mark to a rectangle mark with a height of 2 points. This way, the rectangle mark creates horizontal lines inside the bars showing the average value. You can also adjust the width of these marks. Here, for example, we are setting width to be a ratio of 0.6. This means the width of the bars and rectangles will be 60% of the width of a whole month, as you can see in the screenshot. Finally, we'd like to have an option to show the average daily sales among all the months. To do so, we first set the foreground style to fade gray color to de-emphasize them. Then we add a rule mark outside the for each with y showing the average value. This adds a horizontal rule. To make it clear that the rule is showing the yearly average, we can add an annotation to the rule using the annotation modifier. This adds a text label at the top of the rule mark with leading alignment. We have discussed a couple of examples of building charts by composition. There are many different ways to use and combine these basic marks, like a box plot, multi-series line chart, population pyramid, range plot, steam graph, multi-series scatter plot, heat map, or even a plot of a vector field. These are just some examples of the wide variety of charts you can build with Swift Charts. Let's dive into the next topic, plotting data with marked properties. Swift Charts supports three major types of data: quantitative, nominal, and temporal. Quantitative data is a numerical value, such as the number of products sold, the temperature of a room, or the price of a stock. Swift Charts treats Swift numerical types such as int, float, and double as quantitative data. Nominal data or categorical data represent discrete categories or groups. For example, the name of a person, a continent, or a type of a product. You can use a string or a custom string-valued enum as nominal data. Temporal data represents a point or interval in time. For example, the duration of a particular day, or the exact time of a transaction. Swift Charts treats date as temporal data. The chart works by transforming abstract data, like sales value, into the property of marks. Let's take a look at bar mark, which can plot data with x, y, and foreground style properties. In this example, we plot sales value, which is quantitative, with the x property, and name, which is nominal, with the y property. The resulting chart consists of horizontal bars, each showing sales on x and name on y. If we swap name and sales, such that name is on x and sales is on y, we get a vertical bar chart instead. As you can see, the bar mark's behavior depends on the data type plotted with its x and y properties. The orientation of the bar depends on where the quantitative property is. Now, let's look at another chart with all three properties used to plot data. Here, we plot weekday, which is temporal with x, sales with y, and city with foreground style. The resulting chart is a stacked bar chart, where x-axis shows weekday, y-axis shows sales, and the bars are covered by city. Swift Charts has 6 mark types and 6 mark properties that you can plot data with. Remember that data can be of the 3 kinds, so there's a vast array of possible combinations. This is what allows Swift Charts to support a wide range of chart designs with a small number of basic building blocks. When you plot data with a marked property, for example, sales with y, Swift Charts creates a mapping that transforms the abstract data into a proper value of the property. In this case, if we transform sales value to y coordinates in screen space. We use the term scale to refer to the mapping from abstract data, like sales, to marked property, like y position. You can think of scale as a function that takes data value and returns a property value. For example, here is a y-scale function that takes sales and returns the y position of the bar. The name scale comes from the fact that for position properties, we often scale the input value by some factor to convert it to a reasonable screen coordinate. When you plot data with marked properties, a scale is created to transform the data into the corresponding marked property. For example, in this chart, we have 3 scales, each transforming weekday to x, sales to y, and city to foreground style, respectively. By default, Swift Charts infers the scales automatically from the data, so you get a nice chart out of the box. You can use the scale modifiers to configure the scales in your chart. Let's take a look at a few examples. In this example, the y-scale is automatically inferred to be from 0 to 150. However, we like to fix the y-scale so that no matter what the current sales look like, we always have a consistent y-scale. Let's change it such that the y-scale always starts at 0 and ends at 200. To do so, we can use the chart y-scale modifier and set the domain of the scale to be 0 to 200. Now, as you can see, the axis goes from 0 to 200. Similarly, we can change how the 2 cities map to foreground style using the chart foreground style scale modifier. Now we have 2 new colors for the 2 cities. Now we know how to compose marks and plot data with marked properties. Let's dive into more customization options that Swift Charts provides. A chart consists of axis, possibly a legend, and a plot area. Axis and legend help us interpret the chart. The plot area is the area between the 2 axes. This is where we plot data with marks. All of these elements are customizable in Swift Charts. Let's first see a few examples on how to customize axes and legends. Here is a chart showing total monthly sales. Without customization, Swift Charts generates a default axis that features nicely rounded values. Right now, the axis shows a label for every quarter. Let's change it to show a label for every month and use a single letter month label. We'll start by adding a chart x-axis modifier to customize the x-axis, with axis marks as the content. Axis marks with no parameter recreates the default axis. Let's start by changing the axis values. Since we want to have regular calendar intervals, we can use stretBy similar to the stret function from the standard library. Now we have a label for each month. However, the default labels feel too crowded. As you can see in the screenshot, the labels get truncated because we don't have enough space for them. Let's change the labels to use a single letter format. To do so, let's build up the axis marks from the individual components, including axis grid lines, axis tick, and axis value label. Let's set the format of the label to use narrow month names. Now we have one letter for each month. The value parameter passed into the result builder provides information about the current axis value. You can use this to conditionally determine the existence and style of axis marks. For example, here we have a condition that tests whether the value as a date is the first quarter of a month. If yes, we can highlight the first month of each quarter with a different foreground style. If not, we only display a grid line with a tick and label. Since we are now showing quarters, we can change the format to quarter style. With the customizations we just did, we get a more unique x-axis showing quarter data, with subgrid lines showing every month. In addition to values, axis marks have other properties that allows you to configure the general appearance and style. Suppose we like to have the y-axis appear as a leading edge of the chart instead of the default trailing edge. We can set the position parameter to leading to move them to the leading edge. Swift Charts provides a default preset for the axis marks based on the axis and the type of data being visualized. You can override the default using the preset parameter. For example, here we are using the extended preset for the y-axis to help with visual alignment with the rest of the user interface. In some charts, you may not want the axis to be visible. For example, the purpose of the top sales chart here is to give people a brief overview, so the axes aren't really necessary. You can pass in .hidden to the chart axis modifiers to hide an axis. Legend configuration is similar to axis. For example, in this chart that highlights the best day and location, we already use opacity to highlight the best city, so we can hide the automatically generated legend. To do so, we can add a chart legend modifier with .hidden as parameter. Now let's talk about the plot area. You can use the chart plot style modifier to configure the plot area of a chart. In the trailing closure, we'll write a function that takes the original plot area and returns a modified plot area. Let's see a few examples. In some cases, we might want the plot area to have an exact size or aspect ratio. For example, in this case, we want the plot area's height to be driven by the number of categories in the chart. To achieve this, we can apply a frame modifier to the plot area and return the modified plot area. This will set the height of the plot area. We can also use modifiers to achieve a special visual effect. For example, in this dark mode chart, we use the background modifier to add a pink background with opacity of 0.2 to make the chart stand out a little bit. And then add a 1-point border with the same pink color. This creates a unique visual effect for the chart. Earlier in the session, we mentioned scales, which are functions that map data values to mark properties such as x and y. Swift Charts provides a chart proxy that allows you to access the x and y scales in a chart. You can use the chart proxy's position for method to get the position for given data value, or use the value at method to get the data value at a given position. This allows you to coordinate other views with the chart. Let's look at an example. We're going to build this interactive brushing view. Here you can select an interval from the chart with a drag gesture. And that interval will then be used to filter the rows in the detailed view. We can get a chart proxy object from the chart overlay or chart background modifiers. These two modifiers are similar to SwiftUI's overlay and background modifiers, but they provide you with a chart proxy. To build this example, we'll start by defining the base chart just like before. We then add a chart overlay modifier that provides us with a chart proxy. Inside, we have a geometry reader that gives us access to the geometry of the overlay view. Then, we have a rectangle view that is configured to respond to SwiftUI's drag gesture. When the drag gesture happens, we first find the x-coordinate of the start and the current locations inside the chart's plot area. This is done by subtracting the plot area's origin from the locations provided by the gestures. Once we have these coordinates, we can then use the chart proxy to find the corresponding date values. And finally set it to a SwiftUI state that keeps track of the current date interval. With the range state, we can then define a rectangle mark in the chart to visualize the currently selected date range. This state can also be used to control other parts of your application. For example, to filter the contents of the detailed view below the chart. This is a simple example to illustrate how chart proxy works. You can use it to build many interesting features. For example, this interactive chart that shows the selected day and sales value with an overlay that looks like a lollipop. In this session, we have discussed how to create charts by composing marks, how to plot data with mark properties, and how to customize the chart. You can go to the design sessions to learn more about how to design great app experiences with charts, and how to design an effective chart. We think you will love building data visualizations with Swift Charts. Thanks for watching.